Jai Hind, dear students. I am Dr. Preeti Mittal, and today we are going to revise some very important questions from chemical reactions and equations. So, these questions, if you work out, that will be really very helpful for you all in your exams. So, let's see the balancing of some equations as well as along with the balancing, we are going to work out which type of reaction is that. Okay, so ready with your pen and paper so that you can work it out by yourself and then just check whether you have worked it out correct or not. First equation that you have to balance is lead combines with copper chloride to form lead chloride plus copper. You also have to mention this is which type of a reaction. Okay, after telling you every equation, I'll be working it out and you can check whether what you have done is correct or not. Okay, so the first one, lead plus copper chloride gives lead chloride plus copper. So you have to now balance this. We have just written the formula. Now we have to balance it as well. So here we have two chlorine atoms, here also two. Here we have one lead, here also one lead is there. Here also one copper atom is there, here also one copper atom is there. So it's already a balanced equation only. Now you have to mention which type of reaction is that. I hope you have guessed out that correct. That is a displacement reaction. Okay, this is an example of displacement reaction where lead being more reactive than copper, it displaces copper from its salt solution, copper chloride. Okay, now remember two important things. Every displacement reaction is also a exothermic reaction. Sometimes what is given in the question, that a reaction is given and you are asked the above reaction is an example of endothermic reaction, B exothermic reaction, third is it's a displacement reaction, fourth it's a redox reaction, fifth is a neutralization reaction, and the options are both 1, 2 and 3 or 2, 3 and 4 and whatever it is. Okay, so remember every displacement reaction is also an exothermic reaction. To remember that, you can remember that अपनी जगह से कोई हटाएगा तो गुस्सा तो आएगा, है ना? And when it will become angry, that will become heated up. गुस्से से गर्म हो जाएगा. Okay? तो जब भी जगह से हटाओगे तो गुस्से से गर्म हो जाएगा. And so remember that every displacement reaction is an exothermic reaction. Apart from that, all displacement reactions are also redox reactions. Okay, so displacement reactions are also redox reactions. Fine. Now, second one, work it out. Here, which one is undergoing oxidation and which one is going reduction? For only for this, I am telling you. Next equation onwards, we'll be practicing redox reaction for some other reactions. Okay, in this reaction, there is a reduction of copper chloride to form copper, and there is oxidation of lead to form lead chloride. Okay, there is oxidation of lead and reduction of copper chloride. Fine. Now moving on to the next question, just work it out by yourself. Magnesium combines with oxygen to form magnesium oxide. You have to tell which type and also the balance equation. Okay, pause the video, do it by yourself. I'll be doing it on the board, then you can check out. So magnesium combines with oxygen to form magnesium oxide. Here two oxide items are there, so there also we need to multiply it with 2 ताकि उधर भी 2 हो जाए. Here we have 2 magnesium. Okay, whenever we have metals को कभी भी Mg2 या सोडियम 2 या आयरन 3 ऐसे नहीं लिखते, है ना? जब when we are just not combining their elements, when we are not forming their compounds, in their pure state when we are writing, we write 2Mg, not Mg2. Okay, why is it for metals? Because the metals are not forming bond with other metals. मेटल दूसरे मेटल के साथ में रिएक्ट करके बॉन्ड नहीं बनाता. whereas non-metals form bond with other non-metals. For example, nitrogen combines with another nitrogen atom to form N2, but magnesium is not going to form any bond with another magnesium atom. Okay, so we write two magnesium atoms like this only. Fine. So this is a reaction. Now this is which type of reaction? This is an example of combination reaction, when two reactants are combining together to form a single product. Okay, this one is also a redox reaction also. Third one is zinc oxide plus carbon. I forgot. Zinc oxide combines with carbon to form zinc and carbon monoxide. Okay, work it out. Zinc oxide combines with carbon to form zinc plus carbon monoxide. It's already a balanced equation only. And which type of reaction is that? That is an example of displacement reaction. You can see that it's a displacement reaction. Carbon being more reactive than zinc takes away the oxygen from zinc. Okay, can we move on to the next reaction? Okay, next one is, work it out by yourself. Copper oxide combines with hydrogen to form copper and water. Copper oxide combines with hydrogen to form copper and water. Copper oxide combines with hydrogen to form copper and water. It's already a balanced equation only, and it's an example of displacement reaction. Every displacement reaction is exothermic as well as an example of redox reaction. Okay, so this is also example of redox reaction. Now, next one, copper sulfate combines with zinc to form zinc sulfate and copper. Very easy, na? This is already balanced, and it's also an example of single displacement reaction, or simply we can call it as displacement reaction. So we have worked out certain equations. Now, next one. Copper sulfate combines with iron to form ferrous sulfate and copper. It's also an example of displacement, redox, as well as exothermic reaction. Next one is good one. Silver nitrate reacts with potassium chloride to form silver chloride and potassium nitrate. Okay. Silver nitrate is AgNO3, combines with potassium chloride KCl to form silver chloride plus potassium nitrate. These are some of the questions that I've got from, like, it's released by the RBSC for practice of students for the board exams. But here in this question there is a mistake. It should be like this. It should be the reverse of this reaction. Okay, I'll rewrite that. It should be silver chloride combines with potassium nitrate. Silver chloride combines with potassium nitrate to form silver nitrate AgNO3 plus potassium chloride. And this is an example of double displacement reaction. Okay, why I'm saying that it should be opposite? Because actually potassium and chlorine, this is highly positive, this is highly negative. They have a very strong affinity towards each other. So potassium chloride is a very stable salt, as stable as sodium chloride. Okay, so potassium chloride is the reverse of this reaction, is not possible. Okay. Next one, calcium oxide combines with combines with water to form calcium hydroxide. Do you remember this reaction? Calcium oxide combines with water to form calcium hydroxide. Okay, if you remember, this is the same reaction that we were using before whitewashing. So calcium oxide is a tuna, we dissolve it in water and we get calcium hydroxide. We use this calcium hydroxide to whitewash our walls, and once the walls are whitewashed, then it combines with carbon dioxide present in the atmosphere to form calcium carbonate, CaCO3. Okay, the next reaction also we'll see, but this is an example of an exothermic reaction. It's highly exothermic because it releases a lot of heat. Okay, if you have ever observed that the people doing the whitewash just mix this calcium oxide with water only by using a stick, they never do it by their hand because it's a highly exothermic reaction. Apart from that, this reaction is also an example of combination reaction, when two reactants are combining together to form a single product. Next equation, you have to write the thermal decomposition of ferrous sulfate. Write it by your own. Thermal decomposition of ferrous sulfate. Write it down. I'll then write it down also. Ferrous sulfate is FeSO4. When you are going to heat it, it forms Fe2O3 plus sulfur dioxide plus sulfur trioxide. Since here 2 Fe are there, we need to multiply it here also with 2. Now sulfur 2 atoms are there, this side also 2 atoms are there. Let's count the oxygen to balance our equation. 3 plus 3 6 and 2 8. 4 times 2 is also 8. So this is a balanced equation. That is a thermal decomposition reaction of ferrous sulfate. Okay, next you have to write the thermal decomposition reaction of lead nitrate. Write it by yourself. Thermal decomposition of lead nitrate. Try it by yourself. So I am doing it. PbNO3 whole twice is lead nitrate. When it's heated, it forms lead oxide plus it forms nitrogen dioxide NO2 plus oxygen is formed in the reaction. Here we have 2 nitrogen atoms. Then we need to balance that. If we just do that, then here it's such with 2, but then the oxygen won't be balanced, so we have to multiply it with 2. Here also we'll have 2 lead oxides, and nitrogen is now 4 and 2 times is 4, so it's 4NO2. Okay, so this is a balanced equation for thermal decomposition of lead nitrate. Fine, remember this reaction. Okay, next equation, try to do it by yourself. Sodium sulfate combines with barium chloride to form barium sulfate and sodium chloride. I hope you have dogged it out. Sodium sulfate is Na2SO4 combines with barium chloride BaCl2 gives sodium chloride, that is NaCl, and barium sulfate, this that is BaSO4. Here chlorine is 2, here also 2 sodium atoms are there, so you have to multiply it with 2. Rest everything is already balanced. Next, right, you just need to, for the next equation, you have to just tell it which type of reaction is it. Okay, I am writing the reaction. It's ferric oxide combines with aluminium to form aluminium oxide plus iron. We need to balance it. Okay, you have to write which type of reaction is that. I hope you remember, this is the Thermit reaction. Very, very important for your exams. This is the Thermit reaction that is used to repair the railway tracks. Okay, so it's a highly exothermic reaction like every other displacement reaction. It is also exothermic, but it's so highly exothermic reaction that the iron formed here is in molten state. It's in liquid state. So it is used to repair the railway tracks. Okay. Next reaction also I'm writing on the board. You just need to tell that which type of reaction is that. Okay. MnO2 plus HCl, you have to balance it as well, gives MnCl2 plus H2O plus chlorine. Okay, you need to balance it and you have to tell which type of reaction is that. So I'll balance it. Chlorine is 4 here, 2 plus 2, 4. So I have to make 4 HCl. Since I've made 4 HCl, so it's 4 hydrogen atoms. So it will have to make 2 molecules of water. Okay. Remember, this is given in your book as well, that it is a redox reaction. And here MnO2 is getting converted into MnCl2. That is its reduction. And HCl forming chlorine from it, that is its oxidation. So this is an example of redox reaction where there is oxidation of HCl to form chlorine and there is reduction of manganese oxide to form manganese chloride. Okay, its Mn represents manganese. Okay, last one you have to write the decomposition reaction for calcium carbonate. Thermal decomposition for calcium carbonate. Not only the last one, we are going to practice more. But in this question, according to this question, it's the last one. Calcium oxide plus carbon dioxide will be formed. Okay. So this is which type of a reaction? It's a decomposition reaction, and remember, all decomposition reactions are also endothermic in nature. All decomposition reactions are also endothermic in nature. They are going to absorb heat or sunlight or electricity for carrying out the reaction. Okay, so that is there. And this reaction is also an example of precipitation reaction because barium sulfate is a precipitate. So this reaction is also an example of a precipitation reaction. Okay, I hope this much is clear to you all. We are going to work out some more equations for which you have to write the balanced chemical equation. So let's erase this one. First equation workout. Hydrogen sulfide combines with oxygen to form water and sulfur dioxide. Hydrogen sulfide combines with oxygen to form water and sulfur dioxide. Work it out by yourself. Write down the formula and write and balance the equation. Hydrogen sulfide combines with oxygen to form water and sulfur dioxide. Here, this side we have 3 oxygen atoms and here we have just 2. So, we can make both the sides as 6. 3 2s are 6 and here it will be also 6. So, 6 and there I need to make 2 2s are 4 and 4 plus 2 is 6. So, my it's balanced. Water oxygen is balanced and here also I have to multiply it with 2 so that hydrogen and sulfur are also balanced. Okay. Next reaction I'm writing, you have to just balance that. Iron combines with water. Actually, it's in the gaseous state. It's in the steam only that iron can combine with that that's form Fe3O4 plus hydrogen gas will be liberated out. Okay. The upper one, this is an example of displacement reaction. Okay. This one is also a displacement reaction because what hydrogen is being displaced. So now we have to balance that. So we can make it 3Fe. Now water, it's 4 atoms here. So 4 are there. So I have to make it 4H2O. So that oxygen is balanced. Now that hydrogen, it's 4 molecules of H2 should be there. Okay. So that's how you can balance that. Okay. Next one is what will happen when you just whitewash the walls. Then after some days you observe there is a shiny finish on the walls. What's the reason for that? Write the reaction involved in that. Just do it by yourself. Try to do it and then I'll do it on the board. Okay. So when we perform whitewashing, we use CaOH whole twice. It combines with carbon dioxide present in atmosphere and it forms calcium carbonate plus water is formed. Okay. This is an example of neutralization reaction where CaOH is a base and all non-metal oxides are acidic in nature. So this carbon dioxide is having acidic properties and it forms salt and water. So it's an example of neutralization reaction. Okay. So this we use for whitewashing. It combines with carbon dioxide to form a salt, calcium carbonate and water. Fine. Okay. Next one. Aluminium combines with copper chloride to form aluminium chloride and copper. Just work it out by yourself. Aluminium combines with copper chloride to form aluminium chloride and copper. Now here 3 atoms of chlorine are there, here only 2 atoms are there. So we have to multiply this one with 3 and this one with 2. So on each side we have 6 atoms of chlorine. But by doing that we have made 2 aluminium and 3 copper. Okay. So that is how you can balance that. This is also an example of displacement reaction, redox reaction as well as exothermic reaction. Okay. Next one. Sodium hydroxide combines with sulfuric acid to form sodium sulfate and water. Work out the reaction till it's time. Okay, so this is an example of neutralization reaction. Here 2 sodium are there, so you have to multiply it here also 2. Now let's see the number of hydrogen atoms. 2 plus 2, 4 are there. So I have to take 2 water molecules so that 4 hydrogen atoms are there. That's it also. Okay, so this is a balance equation and this is an example of a neutralization reaction. Okay, now next one is nitrogen combines with hydrogen to form ammonia. This is a neutralization reaction. As acid reacts with the base to form salt and water. Next one is nitrogen combines with hydrogen to form ammonia. Here 3 hydrogen atoms are there, so I will write with 3. 3 2s are 6, so 2 nitrogen atoms is balanced. Okay, or we can start with nitrogen, balancing the nitrogen. So it was 2 nitrogen atoms. So multiply this ammonia molecule by 2. Then we will having 6 hydrogen atoms. So we can multiply it with 3. Okay. Next you have to write, work out some questions. Okay. A compound X when exposed to sunlight produces another compound Y that is gray in color. The compound X is white in color and the compound Y formed after exposure to sunlight is gray in color. Okay, this compound, this reaction and a gas is formed and chlorine gas is formed. Okay, this reaction is also used in black and white photography. Okay, you have to write the reaction. Work it out. I'm waiting for you all to do the equation by yourself. So what we have taken is silver bromide, AgBr. Then when we expose it to sunlight, this silver bromide is white in color. Similarly, silver chloride is also white in color. When exposed to sunlight, forms silver that is gray in color and forms chlorine gas. Okay, to balance, silver bromide we have taken. So what will be formed is bromine. Okay, now to balance it, we have to make it 2 AgBr because 2 Br atoms are there, and here we have to multiply it with 2. Okay. One more thing is there, sometimes you are asked to find out whether a given salt is acidic salt or a basic salt. I'll show you some examples. Okay, so like NH4Cl is there, or you could be asked Na2CO3 or Na2SO4 or NaCl. Okay, so how to identify that the given salt is acidic salt or a basic salt? Remember, when a strong acid reacts with a weak base, then the salt that is formed is a acidic salt. And when a strong base reacts with a weak acid, then the salt that is formed is a basic salt. Fine. But when both are strong acid as well as strong base, then the salt is a neutral salt. Okay. But how we will identify from which salt it has been taken, from which acidic base or acid has been used to prepare that salt, if you're just given the names. So remember, NaOH is a very strong base. HCl is a very strong acid. So if that salt contains sodium, means it is a basic salt. Okay, NaOH is a very strong base, so that will make the salt also basic in nature. So if a salt is containing sodium, that means it is a basic salt. Okay, and HCl is a very strong acid. So if a salt is containing chloride atom, that means it is going to be a acidic salt. It is going to be a acidic salt. Okay, the salts that will be given in the exams will be either containing sodium or containing chlorine. So based on that, you can guess out. Okay, last thing, if NaCl is there, it's having both the strong base and Cl from the strong acid. So it's a neutral salt. Okay, this I've told you extra from acid, bases and salts, but I couldn't control it. I just came across the question and I found that it could be a very important question for exams. Okay, so I thought of sharing it with you all. Okay, so that is there. Next equation, work out by yourself. When lead nitrate is treated with potassium iodide, then a precipitate is formed. You have to write a balanced chemical equation for this reaction. Okay, when lead nitrate is treated with potassium iodide, a precipitate is formed and you have to write a balanced chemical equation for this reaction. This is also there in your book, given as a question, but its answer is not mentioned in the book. So lead nitrate is PbNiTr NO3 whole twice, combines with potassium iodide, that is Ki, gives lead iodide, PbI2, and that only forms a precipitate. Lead iodide is a precipitate form, and potassium nitrate is formed KNO3. Now you have to balance it here. You have two atoms of NO3, two polyatomic ions are there. NO3 is 2, so here also it's to be 2. Here you have 2 iodides, so it has to be 2 Ki. Okay, so this is how you will balance the equation. Okay, I hope it's clear to you all. I'll share some more questions with you all. Okay, quickly tell me the answer. Respiration is an example of which type of reaction? It's an exothermic reaction because energy is produced. The ATP is formed. That is an exothermic reaction. Remember that. Next question, which of these is an endothermic reaction? Okay, I'll be writing 4 reactions on the board and you have to tell me which one is a endothermic reaction. Carbon combines with oxygen to form carbon dioxide. Nitrogen combines with oxygen to form nitrogen oxides. Nitrous oxide it's known as. Hydrogen combines with oxygen to form water. And methanol CH3OH combines with oxygen to form carbon dioxide and water. You have to tell which of these is an endothermic reaction. Okay, in all the reactions we see that it's combining with oxygen only. So how to find out that it's endothermic reaction? Actually, when you practice more now, you come to know about all these things. But in this question, you can work it out on deductive logic. Means you can rule out that this couldn't be endothermic, this couldn't be endothermic. Then whatever is left out, that should be the endothermic reaction. Try it that way. You will be able to figure out which one is endothermic. Okay. Now you know. It's burning of carbon, burning of coal. That is involving C plus O2 gives CO2. So it's always exothermic only. Okay, I don't know about this reaction. Leave it for now. This, you know that water decomposition is endothermic. So when you have to break water, you have to use energy so that H2 plus O2 will be formed. Electro decomposition. But the reverse of that will be exothermic. So इसका उल्टा एंडोथर्मिक है, तो अगर ऐसा होगा तो that will be exothermic. That is exothermic reaction. Now this is combustion of methanol. So alcohol, when it undergoes combustion, forms carbon dioxide and water, and that is also an exothermic reaction because that could be used as a fuel. So whatever is left, that is an endothermic reaction. And remember, nitrogen combines with oxygen to form nitrogen oxide. That is a endothermic reaction. This reaction requires energy. Okay. Okay. Now, next question. Lead oxide combines with carbon to form lead and carbon dioxide. Which is not true about this reaction? You have to tell what is not true about this reaction. So, I am just writing it on the board. Lead oxide combines with carbon to form lead plus carbon dioxide. What's not true about this reaction? First, lead is undergoing reduction. Second, oxidation of carbon dioxide is taking place. Third, oxidation of carbon takes place. Or reduction of lead oxide takes place. So let's work out what is undergoing oxidation and what's going reduction. So you all know that carbon undergoes oxidation to form carbon dioxide. and lead oxide undergoes reduction because there is removal of oxygen to form lead, and that is a reduction process. So, what's not true about this reaction is first and second. Lead is undergoing reduction? No. Lead is not undergoing reduction. It's lead oxide that is undergoing reduction. What is not true is oxidation of carbon dioxide is taking place. Oxidation of carbon is taking place. Oxidation of carbon dioxide is not taking place. So, first and second are incorrect. Okay. The options were first and second are incorrect, or third and fourth are incorrect, or all of these are incorrect, or first, second, and third are incorrect. Okay. So, out of the four options, first and second are incorrect. Okay. Um, so we have worked out many equations. Let's work out a few redox reactions. Okay, so this one is we have already practiced that which one is undergoing oxidation and which one is going reduction. Okay, manganese oxide one also we have seen that which one is going oxidation and which one is undergoing reduction. Let's work out one more last reaction. Copper oxide combines with hydrogen to form copper and water. Okay, so in this reaction, work it out by yourself. Copper oxide undergoes reduction and there is oxidation of hydrogen to form water. Whenever you have any question based on redox reactions, then you can work it out in this way. Showing the arrows, you can explain which one is undergoing oxidation and which one is undergoing reduction. Now the last question and we'll end up with the video. Burning of magnesium ribbon is oxidation, reduction, both or none. Work it out. Burning of magnesium ribbon is oxidation reaction, reduction, both or none. So remember, in this question, when there is oxidation of magnesium, there is also reduction of oxygen. There is reduction of oxygen. And so, this reaction is both oxidation as well as reduction. Whenever one compound is undergoing oxidation, the other one always undergoes reduction. Okay, so the answer is both. Okay, I hope you will be able to balance all the equations. You will be able to figure out which type of a reaction is there in the question, and you will be able to get very good marks in your exams. Okay, that's all for today. Good day everyone.